Good morning, students. We are going to see last topic from our chemistry syllabus, that is green chemistry and nanochemistry. Weightage for this topic for board exam is 3 to 4 marks. Now first we must know what is meant by environment. Environment consists of living and non-living things or the conditions in which you live or work, etc. Factors affecting on environment. The environment is affected by abiotic and abiotic factors. Now in which abiotic factors are temperature, pressure, humidity, human activity, greenhouse effect, etc. Biotic factors are availability of food, competition, predators, parasites, etc. Now we must know what is meant by pollution. Now, introduction of harmful material into environment. These harmful material are called pollutant. Pollutants can be natural such as volcanic ash, or it may be produced by industry, factories, etc. Now there are types of pollutions which are water pollution, air pollution, sound pollution. Because of these pollutions, our health and global environment are under threat. Also due to increase in human population and the industrial revolution, energy crisis and environmental pollution are highlighted major global problems in the 21st century. To minimize the problem of energy crisis and pollution, we have to adapt green chemistry. Now first we are going to see what is meant by green chemistry. Green chemistry is the use of chemistry for pollution prevention by environmentally conscious design of chemical products and processes that reduce or eliminate the use of generation of hazardous substances. To reduce the impact of energy crisis, pollution, and to save natural resources, we need to implement 12 principles of green chemistry, which are put forth by Paul Anasta wherever possible. Now we are going to see sustainable development. Green chemistry plays an important role in sustainable development. We can achieve sustainable development by adapting the 12 principles of green chemistry. Now we are going to see principle of green chemistry, in which first is prevention of waste or byproducts. To give priority for the prevention of waste rather than cleaning up and creating waste after it has been created. For example, to develop the zero waste technology, that is ZWT. In terms of ZWT or zero waste technology, in a chemical synthesis, waste product should be zero or minimum. It also aims to use the waste product of one system as the raw material for the other system. For example, bottom ash of thermal power station can be used as a raw material for the preparation of cements, bricks industry, etc. Influent coming out from the cleansing of machinery part may be used as a coolant water in thermal power station. That is, here we have to prevent the creation of waste or byproducts or use of this waste product in some other processes. Second is atom economy. Atom economy is a measure of the amount of atoms from the starting material that are present in the useful product at the end of chemical processes. Good atom economy means most of the atoms of the reactants are incorporated in the desired products and only small amount of unwanted byproducts are formed, and hence lesser problems of waste disposal. For example or illustration, the concept of atom economy gives the measure of the unwanted product produced in a particular reaction. Now next, less hazardous chemical synthesis. Design chemical reactions and synthesis route should be as safe as possible so that we can avoid formation of hazardous waste from chemical processes. For example, earlier DDT, that is dichlorodiphenyl trichloroethane, was used as an insecticide and which was effective in controlling diseases like typhoid and malaria carrying mosquitoes. If it was realized that DDT is harmful to living things, nowadays benzene hexachloride, that is BHC, is used as an insecticide. One of the gamma isomer of BHC, that is benzene hexachloride, is called gamma hexane or indane, which is used as an insecticide. Designing safer chemicals. This principle is quite similar to the previous one. To develop products that are less toxic or which requires less toxic raw material. Illustration for this, that is, for example, in chemical industries, workers are exposed to toxic environment. In order to prevent the workers from exposure to toxicity, we should think of designing safer chemicals. For example, adipic acid is widely used in polymer industries. Benzene is the starting material for the synthesis of adipic acid. But benzene is carcinogenic and benzene being volatile organic compound pollutes air. In green technology developed by Drath and Frost, adipic acid is enzymatically synthesized from glucose so that benzene is avoided for the preparation of adipic acid. Next principle is use safer solvent and auxiliaries. Choose the safer solvent available for any given step of the reaction. Minimize the total amount of solvents and auxiliary substances used as these make up a large percentage of the total waste created. Illustration for this. The main aim behind this principle is to use green solvents. For example, water, supercritical CO2 in place of volatile halogenated organic solvents. For example, CH2Cl2, CHCl3, CCl4, that is dichloromethane, trichloromethane or tetrachloromethane used as a solvent in many chemical reactions as that dissolve solutes and form solutions facilitate many reactions. But water is a safe being solvent while dichloromethane is hazardous. Use of toxic solvents affect millions of workers every year and has implication of consumers and the environment as well. Next principle is design for energy efficiency. Chemical synthesis should be designed to minimize the use of energy. It is better to minimize energy by carrying out reaction at room temperature and pressure. This can be achieved by use of proper catalyst, use of microorganisms for organic synthesis, use of renewable materials, etc. Illustration for this. The biocatalyst can work at the ambient condition. Similarly, in chemical synthesis, refluxing conditions requires less energy. Improving the technology of heating system. Use microwave heating, etc. Now next principle is use of renewable feedstocks. Use chemicals which are made from renewable, that is from plant-based sources rather than other, for example crude oil, that is petroleum products. Petroleum products are non-renewable sources of energy. Now we have to use renewable sources of energy. For example, over exploitation of non-renewable feedstocks will deplete the resources and future generation will be deprived. Moreover, use of these non-renewable resources puts burden on the environment. On the other hand, use of renewable resources, for example agriculture or biological products, ensure the sharing of resources by future generation. This practice generally does not put much burden on environment. The product and the waste are generally biodegradable. Next principle is reduce derivatives, that is minimization of steps. A commonly used technique in organic synthesis is the use of protecting or blocking group unnecessarily derivatization, for example, installation, removal, use of protecting groups should be minimized or avoided if possible because such steps requires additional reagents and can generate waste. Illustration for this, in organic synthesis we need very often protecting of some functional group. Finally, we again need their deprotection. It is explained in the following example of synthesis of metahydroxybenzoic acid from metahydroxybenzaldehyde. Now look this. Obviously in such cases atom economy is less. The green chemistry principle aims to develop the methodology where unnecessary steps should be avoided. If practicable, biocatalytic reactions very often need to protection of selective group. Now in this reaction, metahydroxybenzaldehyde is converted into metahydroxybenzoic acid. Here, this reaction is carried out first protecting this OH group. This OH group is protected by the reaction of this metahydroxybenzaldehyde with C6H5CH3Cl, that is benzyl chloride. Now here this hydrogen atom is replaced by CH2C6H5 group, that is alkylation of this hydroxy group is carried out, and then oxidation of this CHO group is carried out, which is converted into COH group, that is this aldehyde group is converted into carboxylic group, and then again deprotection of this OH group is carried out, that is this CH2C6H5 is removed and it is replaced by hydrogen atom to give metahydroxybenzoic acid. In this step, deprotection of OH group is carried out. Then use of catalyst. Use of catalyst is the chemical reaction speeds up its rate, that is catalyst used to increase the speed of chemical reaction. Catalyst helps to increase selectivity, minimize waste and reduce reaction times and energy demand. Next principle is design for degradation. Design chemicals that degrade and can be discarded easily. Ensure that both chemicals and their degradation products are non-toxic, bioaccumulative or environmentally persistent. Ensure that both chemicals and their degradation products are non-toxic, bioaccumulative or environmentally persistent. Illustration for this. The aim behind this principle is that the waste product should degrade automatically to clean the environment. Thus the biodegradable polymer and pesticides are always preferred. To make separation easier for the consumer, an international plastic recycle mark is printed on larger items. Real-time analysis, pollution prevention. This is next principle. Analytical method need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substances. Now illustration for this. Analytical methodologies should be developed or modified so that continuous monitoring of the manufacturing and processing units is possible. This is very much important for the chemical industries and nuclear reactors. Next principle is safer chemistry for accident prevention. We need to develop chemical processes that are safer and minimize the risk of accident. Illustration for this. The substances to be used in chemical reaction should be selected in such a way that they can minimize the occurrence of chemical accidents explosions, fire and emission. For example, if the chemical processes works with the gaseous substances, then the possibility of accident including explosion is relatively higher compared to the system working with the non-volatile liquid and solid substances. Now we are going to see the role of green chemistry. The green chemistry approach recognizes that the earth does have a natural capacity for dealing with much of the waste and pollution that society generates. It is only when that capacity is exceeded that we become unsustainable. To promote innovative chemical technologies that reduce or eliminate the use of generation of hazardous substances in the design, manufacture and use of chemical products. The green chemistry helps to reduce capital expenditure to prevent pollution. Green chemistry incorporates pollution prevention practices in the manufacture of chemicals and promotes pollution prevention and industrial ecology. Green chemistry is a new way of looking at chemical and their manufacturing process to minimize any negative environmental effects. Green chemistry helps to protect the presence of ozone in the stratosphere, essential for the survival of life on the earth. Green chemistry is useful to control greenhouse effect, that is global warming. So we should think about save environment and save earth. So that we must follow this 12 principle of green chemistry. Thank you.